of how metals reacted with oxygen. So K and Na reacted at almost room temperature to form K2O and Na2O. Calcium and magnesium required heat to react with oxygen. Aluminium and zinc. Remember, we used a larger fire to react aluminium and zinc. That means it required strong heating. But iron, even on strong heating, was not reacting. So we decrease the surface area, increase the surface area, increase the rate of reaction, heat, filings. It is not fillings, filings. Lead, however, is not there in our syllabus, so we are going to omit it, but you can react it by heating their filings. Copper reacts on strong heating, but it does not burn like all the other metals. So it only forms a layer of black copper oxide. So does aluminium with a dull layer of aluminium oxide. The rest of the metals at very, very, very high temperature react with oxygen, but that is not physically possible, so we are not going to study this in this syllabus. Moving on to the nature of these oxides. Most metal oxides are insoluble in water. I mean, even if you put it in water for 10 days, they are not going to dissolve in it. But some of these dissolve in it and form alkalis. What are alkalis? Water-soluble bases. K and Na oxide dissolve in water to produce alkalis as follows. When K2O reacts, or when it reacts with water, what happens is it forms KOH aqueous. So we'll study the reaction. K2O plus H2O forms KOH aqueous. K2O, potassium oxide, H2O, that is water, and KOH, that is potassium hydroxide. So in this reaction, you have to balance this reaction. K is 2 on the left hand side, right hand side is just 1. So what will you do? Multiply by 2. O becomes 2. O is already 2. 1 plus 1, 2. Hydrogen is 2. Hydrogen is already 2. Let's see the same reaction for Na2O. When Na2O is put in water, it quickly dissolves to form NaOH. NaOH aqueous. So this NaOH, let's balance this reaction also. Sodium oxide, when reacts with water, it gives me sodium hydroxide. Na is 2 on the left hand side, 1 on the right hand side. So you multiply it by 2. Oxygen is 2 on the right hand side, and if you see on the left hand side, look closely, 1 plus 1 is 2. Hydrogen becomes 2, multiply by 2. Now moving on to the nature of these oxides. These oxides, how will they react with acid and base? Well, you know for a fact that acid plus base gives you salt and water. Acid plus base will give you salt and water, and this reaction is called as the neutralization reaction. Basically, there are two properties, acidic properties and basic properties. Acids neutralize base, base neutralize acids. Hence, there is a lot of neutralization happening, hence the name neutralization reaction. Let's see what happens when you react a metal oxide with the acid. When you react with a metal oxide, an acid, they form salt and water. They form salt, which is a metal and a non-metal, and water. So you have salt, you have water, you have acid. What do you think metal oxide is? It is not a base, but it sure does behave like a base. So when it behaves like a base, I can confidently say that metal oxides are basic in nature. But there are two exceptions. Aluminium oxide and zinc oxide do not only react with acid. They react with acid as well as base to form the salt and water. So when they do so, they are called as amphoteric oxides. Like amphibians, like crocs, which live in water, they live on land. Similarly, Al2O3 reacts with acid as well as base to form aluminate ion, and zinc forms zincate ion when they react with a base. We'll see that in the next slide. Aluminium oxide and zinc oxide. Moving on to non-metal oxide. These generally do not react with acid, but they do react with the base to again form salt and water. So non-metal oxide react with salt and water to produce Salt and water. So there is salt, there is water, there is a base. What do you see is missing? Acid. And non-metal oxides are generally acidic in nature. With this, we finish the nature of oxide. Come back to learn how do amphoteric oxides react with acid as well as bases.